Hello, my geometry students. It is day 6 of Unit 3, and we're going to be doing more with proving triangles congruent. So you have 2 new methods to talk about for today. Let me see if I can turn on. There we go. A little light there. And you can see at the top, it's ASA and AAS. So based on what you know already, you probably know what those stand for. So the first method, ASA, is really short for angle, side, angle. And what that means is that you have 2 angles, or 2 sets of congruent angles and 1 set of congruent sides, but the side has to be in between the angles. So we list it in that order because that's the order it has to show up in the triangle. All right. So if we just kind of play the game over here, we could say that, all right, angle A, let's say, is congruent to angle D. And it's because I'm giving it to you that it's a given. All right. And then angle B congruent to angle E. All right, this would be one angle. Here's a second angle. For it to be angle, side, angle, it has to be the side that literally falls in between the 2 angles, or as if you were to connect the corners. So if I connect A to B, I'm highlighting that side between them. That's the side that I would have to have. So I would have to know that side AB is congruent to, again, connect angle D to angle E, that side that connects them. That would be the side I need. So DE. So if AB is congruent to DE, there's my pair of sides. And again, I'm going to say it's given to you. And that would allow me to say that triangle ABC is congruent to triangle DEF. And then my reasoning. I only ever look at one triangle when I come up with the reasoning. I've got 2 angles in the side between. So here's angle, side, angle right there. So we can say angle, side, angle is congruent to angle, side, angle. Or feel free, you can always shorten it just to ASA, written that one time. All right, I want you to see that in direct comparison to the next one. The next one is AAS. So we know that's shorthand for angle, angle, side. So it's still the same 3 parts. It's still 2 angles and 1 side. The difference is how they line up with each other in the diagram. So to show you that, let's use the exact same pairs of angles this time. So over here in the proof, let's say that angle A is congruent to angle D and angle B is congruent to angle E. So that's going to be your 2 pairs of angles because it's given, because I'm giving them to you now. And go ahead, I'm going to slide up just a touch so you can see. And let's mark them in the picture. So angle A and angle D, angle B and angle E. All right. The difference this time is if it's listed as angle, angle, side, it is very specific that the side is not between the angles. So I would have to know one of the sides are congruent. That's not the side in between. So it can't be sides A, B, and DE. So it could be that you know that BC is congruent to EF, or it could have been that AC is congruent to DF. So I'm going to go with the first one here. I'm going to say that BC is congruent to EF. Again, I'm giving that to you, so it's a given, right? In an actual proof, we'd have to be told it in a set of givens, or we'd have to discover it based on some information they're giving it to us. But otherwise, that's my pair of sides. And then I'd be able to say triangle ABC is congruent to triangle DEF, and it would be by angle, angle, side. Because when I look in the picture, angle, angle, and side over here. All right. So you may want to write yourself a little note before we move on. Here, the side is between the angles. So you literally connect like the 2 vertices of the angles, and that's your side. Here, I'm just simply going to say the side is not between the angles. Right? So you have to specifically say, okay, here's my 2 angles. Does the side fall between it? Or here's my 2 angles. Nope, it's over here. That's AAS. So really need to use your diagram to be able to focus on that. So the 4 methods that you know at this point, we got side, side, side. We got a little SAS, a little side, angle, side. We've got angle, side, angle, and we have angle, angle, side. All right, so down at the bottom, and it says, what is not a method for proving triangles congruent? What I mean is like what combinations. So we've got all three sides will prove angles congruent, a mixture of sides and angles. So what combos have we not thought of yet? All right, well, you might be thinking like, would angle, angle, angle work? Nope. It'll prove the triangles are the same shape. It would not prove them to be congruent because one could be much bigger than the other, like a dilation essentially. And so that doesn't work. Another one, angle, side, side, and I put little periods between. And yes, it spells out what you think it does there. So note to self, if it's going to spell a naughty word, it does not prove triangles congruent. Something to keep in mind, this in reverse would be side, side, angle. That one still doesn't work. All right, so if it's going to spell something inappropriate or even in reverse inappropriate, does not work. So that works out nicely for me that we don't have to have that as a reason. And then all angles, that's not going to cut it. Right? So let's actually give this a try. Flip it on over to that next page. And keep in mind, we got lots of new methods here. Oh my goodness, I'm struggling. There we go. So on the next page is just some quick practice of can you recognize which method it would be. So it's saying for each set of triangles shown, determine if the triangles are congruent by angle, side, angle, or angle, angle, side. So I would always say, I have a little post-it here, I'm going to cover up one triangle. I only need to see one of them. So I don't need that second one for this first one. If I look here, here's my two angles. And if I look at the side connects one angle to the other, that's a really good example of angle, side, angle. So we would say ASA. Right? There's number one. When you look at number two, again, I only need to look at one triangle, so just ignore the other one. Here's my two angles, and the side in between is not the one marked. It's this side over here. So that's an example of angle, angle, side. Right? Now, where the post-it comes in kind of handy is when the triangles are connected to one another. Right? So when you look at like number three, I'm going to very carefully cover up one of those triangles. And if you don't have a post-it, just use your hand and cover one up. But otherwise, then you can see here's the two angles. This is the side that would connect them, which is not the side that's marked. It's this side over here. So this is angle, angle, side, just like that. Mm-hmm. And then I would suggest grab a piece of paper, use your hand, whatever, cover it up. Take a look. It doesn't matter which triangle you look at, just look at one of them. So here, I've got my two angles, so angle and angle. And the side that's marked is the side that connects the two angles. So since it's the side between, this is angle, side, angle, just like that. All right. The next few, you can practice them on your own now. Otherwise, we'll save them for a little recap for class. So feel free to try them out and then we'll check them over in class. Or if you're not feeling super confident, then wait until I see you and then we'll go over them. All right, on to the next page. Let's try some proofs here. So reminder, with your proofs, here's where you actually have given. So it's not just me saying, hey, write that down. So we start always with a given. And then it's always good to look ahead and think, like, where are we going with this? So I want to prove triangle ABC is congruent to triangle DEC here. That makes sense. All right, so we are told that C is the midpoint of segment AD, and that is given. Now you can put both givens together. I like to split them up if I have a vocab word to go on, just because I like to make sure that we don't forget to use this guy. So here's my vocab word. If you've got a highlighter, it's a great place to use it. So if I'm told that that's a midpoint, then down here, that's what I should be talking about. I should be saying, well, midpoint tells me what? So if I have a midpoint, you can go back to your sheet if you need to. Otherwise, we should know midpoint is going to break up a segment into two congruent segments. So look at your picture. If C is the middle of segment AD, then that segment is getting broken up into two congruent parts. So I should be able to say that AC is congruent to CD. Midpoint implies two congruent segments. There's a pair of sides right there. All right. Next up, I'm going to throw my next given in. If you already put it in step one, perfectly fine. But angle B being congruent to angle E, that's a pair of angles. So they're just handing you a pair, which is nice. All right, we are out of givens. So here's where I look to the diagram. What can we say just from looking at the diagram? Well, when we see that nice X shape in the middle, we have those angles across from each other that we know are congruent, that are vertical angles. So please don't refer to this as angle C. There's too many things going on. So it's either angle BCA and angle ECD, or you can call it 1 and 2. All right. I'll go with the letters this time. I'll probably go with numbers next time. So angle BCA is congruent to angle ECD, and that is because vertical angles implies congruent angles. All right, there's another pair of angles. Now all we have to figure out is what order are they in to get triangle ABC congruent to triangle DEC. All right, well, if I look, cover up one of those triangles. I'm gonna bring my Post-it back in, so I don't need to see that triangle. If I look here, here's my two angles. The side that would connect them would be this side, but that's not what I have. I got this side. So this is angle, angle, side right here. And again, you can say angle, angle, side congruent to angle, angle, side, or just one of them. I will accept it either way. All right. I love this next proof. Let's do this one. And then we're going to save some of these to look at in class. But as you could guess, you're trying to prove the triangle at the top. ABC is congruent to the triangle at the bottom, CDA. And what we're being given, we've got parallel lines here. So BC is parallel to AD, given. Now I'm going to sort of break my rule a little bit. That's a vocab term right there. But because in the second given, that's the same vocab term, I'm going to put them together just so that I can kind of condense some of the statements that are going to follow here. So AB is parallel to CD. All right, so let's look at the picture. So BC is parallel to AD. And keep in mind, I can put the little arrows on to show it. AB, double arrow, is parallel to CD, double arrow. Okay. Let's talk about what parallel should give us. So when we have parallel lines, that's going to give us, in this picture, congruent alternate interior angles. Now, it could have been corresponding angles, but if you look at what we have here, I'm not only going to highlight my vocab term here and show how we carried it down, but I'm going to use like the first set and say that here's BC and here's AD that are parallel. And when I connect it to that transversal there, there's that Z shape popping out. And the alternate interiors are in the crooks of that Z shape. So the first set of parallel lines, here's where I'm going to use numbers to make life easy, gives me this pair right here. So I'm going to call that angle 1 and angle 2. So that tells me angle 1 is congruent to angle 2 because those are alternate interior angles. But we also have the second pair of parallel lines. So if I highlight this parallel line and this parallel line and kind of connect it, whoa, my red pen's a little dead here. Connect it. You can see that you get like an N shape almost, but it's a sideways Z, if you will. You get this pair of alternate interiors in the crooks. So I'm going to call that 3 and just call that guy 4. All right. And so that gives me another pair of angles that are also alternate interiors. So right there, here's a pair of angles. Here's a pair of angles. You've got two angles in your picture, and we're out of givens. So when you look at the diagram, we don't have the X shape this time. But what we do have is we have the same side overlapping in each triangle. So we can use the fact that they share that middle side, AC, to our advantage. So AC is congruent to AC. That is referred to as the reflexive property. All right. So since we have a side now, all we need are 3 parts. 2 angles and a side means let's stop and take a look at what we have. So I have a lot of stuff drawn on my diagrams. I'm going to do my best to cover up one diagram. Okay. What you have to be really cautious of is the arrows are not congruent symbols. Either a tick mark, or in this case, the X is the congruent symbol. So when I see my 2 angles here, it's the side connecting in between them that is marked as congruent. The other two sides are marked as parallel, which does not have anything to do with being congruent. So I have angle, side, angle right here. All right, so I can go ahead so I don't forget it and put it right down here. And then I can say triangle ABC is congruent to triangle CDA. And then that's my finished step. Feel free to add in the congruent to angle, side, angle, because that's what we're saying. This angle, side, and angle are congruent to that angle, side, and angle. Right? Oh, let's see what's left here. So on the next page, you have two more proofs. So this first one, we got a little vocab, we got a little bisector going on. The second one, we've got a little perpendicular happening. I'm thinking, let's save both of these for class for tomorrow. So write a little note up here to say that we're going to recap those later. But then still, you got a little post-video question asking you about this. So make sure to go finish that up right now. Thanks so much for watching, guys. See you soon.